Good day, everyone. Welcome back to the Doc of Detox show. Today's show is The Power of Structured Water with Dr. Gerald Pollack, who has received his PhD in biomedical engineering from the University of Pennsylvania in 1968. He then joined the University of Washington facility and, no, let me start over. I said it wrong. Okay. Facility. Is not faculty.
So we have the time to edit this in, so you can just start from
Okay.
zero.
All right. Good day, everyone. Welcome back to the Doc of Detox show. Today's show is The Power of Structured Water. And my guest today is Dr. Gerald Pollack, who received his PhD in biomedical engineering from the University of Pennsylvania in 1968. He joined the University of Washington faculty and is now the professor of bioengineering. In 2008, his colleagues chose him as the recipient of his university's highest annual distinction, the UW Faculty Lecturer Award. Dr. Pollack is a founding fellow of the American Institute of Medical and Biological Engineering and a fellow of both the American Heart Association and the Biomedical Engineering Society. His book, Muscles and Molecules, Uncovering the Principles of Biological Motion, won an Excellence Award from the Society of Technical Communication. His book, Cells, Gels, and the Engines of Life, and his newest book, The Fourth Phase of Water, Beyond Solid, Liquid, and Vapor, won that society's distinguished award, their highest distinction. The latter book went on to receive the World Summit Excellence Award. It is my deepest honor to be able to interview who I feel is a world leader, not just in water, but many things that come in the form of science. Dr. Pollack, I know that you have an extensive background, but can you please share that with us?
Well, sure. Thank you, Darrell. I really appreciate that generous introduction. Background. Well, I came, as you said, to the University of Washington right after my PhD, and I was intrigued by the subject of muscle contraction, trying to figure out how the molecules interact with one another, the actin and myosin and other less major proteins to produce force and motion. There was a theory, there still is a theory, that was out at the time, and it was put forth by a highly distinguished Nobel laureate, Sir Andrew Huxley, who passed about 5 or 6 years ago. And he was a guy with as many major distinctions as you can guess. He won a Nobel Prize. He was knighted by the Queen. When he walked into the room, there was a hush. There was only one problem: his theory didn't fit the evidence. And still, the theory doesn't fit the evidence. On the other hand, his theories are pretty well accepted by most. And so I was in that field for quite a few years. And it was really fun because we were doing frontline experiments, but almost nobody cared about the results because this great hero was the leader of the field. And the fact that the results didn't fit the theory were seemingly ignored by most. So during this period of time, as we were beginning to develop new ideas about how the muscles might actually contract, I began thinking about the major constituent of muscle, and that is not the proteins, it's not nucleic acids, it's water. And so in terms of the percentage by volume of water inside the muscle, it's, depending on your muscle and your age, roughly 2/3 by volume. But if you do the count in a different way, if you were to line up all the molecules, every molecule inside the muscle, and start counting one by one, it would turn out that more than 99% of those molecules are water molecules, because to make up that 2/3, you need a lot of these tiny molecules. So it struck me as preposterous that 99% of the molecules that are inside the muscle don't do anything. They just sit there bathing the supposedly more important molecules of life. This struck me as unreasonable. But the people in the field had no inkling that water might actually play a role. By coincidence, I came to meet a scientist who's now 100 years old, Gilbert Ling. And Gilbert Ling had come from China. He was among a rather distinguished group of people coming from China. They picked, after World War II, Chinese scholars began coming to the US. And in the first cohort were 3 people, one of whom went on to win a Nobel Prize in physics, who was actually better known for the fact that when he was in his late 80s, he married his translator, who was in her early 30s. That was really interesting, especially to all the Chinese people. But I had the sense that they all thought that Gilbert Ling was the smartest, and Gilbert Ling had revolutionary ideas. He said that in the cell, the water was not like any old water, like water in a glass. The molecules were in a different configuration. They were actually lined up like soldiers at attention, lined up. And I came to meet him at a conference, and I found myself totally impressed. He'd written by that time 4 books. Most of them dealt with water, plus a few other controversial areas of biological science. And I showed one of his books to my students and postdocs, and every one of them who looked at it came back and said, this guy is either right on or so close to being right on that this work is of extreme importance. So that's when I kind of switched gears, because I thought this is so important, not only for muscle contraction, but for everything the body does, that I decided to write a book. And the reason for writing the book was that Gilbert Ling, although extreme in his brilliance, Gilbert Ling has a tendency to write, and advanced physical chemists maybe have no difficulty understanding it, but the rest of us, it's a formidable exercise to try to get the details of what he's saying and understand all the evidence. So I wanted to write a book that took Gilbert Ling's ideas and translated them into, if you pardon the expression, English, so people can understand.
Yes.
And that's how I got into it. Yeah. Sorry.
So are we going down the path that the water holds the memory that causes the muscle memory?
Yeah, well, yes and no.
Okay.
We are going along that path. We haven't gotten there yet. It's not just muscle memory, but it's memory. I mean, now that you mention it, so the answer is yes. There are a few steps before we embark on that path.
Okay.
I mean, I'm happy to go right to it if you like.
No, I don't want to.
Okay. Yeah.
I want my listeners to know step by step. Let's take our time. This is fascinating.
Oh, okay. Well, thank you. It is to me, I've got to tell you. So the book, the Cells, Gels, and the Engines of Life, it went beyond what Gilbert Ling had suggested. And the book adduced evidence to demonstrate that water was not only ordered, as Gilbert said, but that the water itself, the ordered water, was so central to practically every major event that occurs in cell biology, not just the contraction of muscle, but the working of nerves and secretory cells and mitosis, all of the ones that you've learned about, in middle school, a little bit and such. But the water was central. It's not really a background carrier of the more important molecules of life. It plays a critical and central role in everything that the cell does. So that was, and once we did that, we started to do experiments because we were curious about this really important aspect of water and the critical nature of the role of water in everything we do, and completely or almost completely unrecognized. So we started doing experiments. We found out a lot about the water, and let me just tell you about this so-called structured water. We found that it has a different structure from what Gilbert Ling suggested. It actually consists of sheets and stacked sheets of a kind of water, and these sheets are hexagonal in nature. So you've got one sheet, another sheet, another sheet, and this kind of water grows at interfaces. So if you have, for example, if you have a protein interface between the protein and the water, what happens is that the protein will convert the water into this special kind of ordered water. We call it fourth phase water. We also call it exclusion zone or EZ water. It makes for, it's easy to remember, but it doesn't always work because too many people use EZ instead of EZ. But otherwise, it's fine. And it has a couple of interesting characteristics that are, I think, really important. One of them is, in order to build it, in order to take ordinary water where the molecules are not so well or not organized at all, and convert it into this regularly organized, almost crystal-like water, you need energy. Energy to convert chaos into structure, into order. Energy, it's a fundamental principle of thermodynamics. And so the question is where the energy comes from. And after 2 or 3 years of scratching our heads and being unable to find the answer, actually it was a student who found it, an undergraduate student. He found it was light. Light's all around us, and especially we found it's infrared light. Infrared light is all over. It comes from virtually everywhere, and most people are not so familiar with infrared light. So if you take a room and darken it so that you see nothing, your eyes, it looks completely dark and black. And if you pull out your smartphone camera, you get no image. But if your smartphone camera has an infrared sensor instead of a visual light sensor, it'll pick up beautiful images of everything, of you, your jacket, your shirt, the scenery behind you, because it's all emitting infrared energy. So it's not just the your electric range that glows bright orange that generates heat and infrared. It's also everything around you. And so because that energy is always there, it means that the EZ or fourth phase water is always there because you have the energy available to build it.
Sir, can I ask you a question? How does the infrared, okay, it's dark. How does the infrared do this? Do you know that? Do you know the science behind that? How you can use the infrared and it'll actually see different shapes, images in the dark?
Well, everything is generating infrared. So
okay,
and your camera, it picks up basically the energy, the light energy. It picks it up and puts it into focus, so you get an image. So if I'm looking at you, you're actually the light that comes from the sun or whatever lamp you have is getting reflected off your camera, and so I can get an image, just like the image I'm seeing right at the moment. And the same thing is true of infrared. It could be reflected off the surface, but also it's actually generating the infrared itself. And because that light, the electromagnetic energy is coming from you and from your jacket and shirt and such, my camera picks it up. Infrared.
Wow.
Yeah. So it's like a night light that's used in military, to find out where the enemy lurks.
Right.
But it's all over the place, and that's the energy. So that's another. In a way, it's like photosynthesis, because when light, and that usually is visible light, hits the plant undergoes a series of chemical reactions that produces energy. Well, this is much the same. What we found is that this fourth phase of water, which builds with infrared light, actually typically it's not neutral like ordinary water, has a negative charge. And the region beyond it, region of ordinary water, takes on a positive charge. So it's like a battery with the EZ or fourth phase water typically being negatively charged, and the region beyond having the complementary positive charge. And the way it happens is the water molecules actually split, and it's split into H plus and OH minus. And the OH minuses gather to form this fourth phase of water, these hexagonal sheets that I mentioned to you. And the H plus part just goes into the water and forms either protons or hydronium ions, which are protons associated with water. Why am I mentioning this? I'm mentioning it because this is a source of energy. So our bodies are filled with this kind of water. It's not H2O that fills our body. The evidence is our body is filled with this fourth phase water. And this fourth phase water contains energy. So basically, we're not so different from plants. The plants receive the light energy. And step one in the photosynthetic process is the dividing of water into its component parts, into H plus and OH minus. And there are a whole series of steps beyond that, explaining how carbon is built and such. So we don't undergo those steps. But I think we actually undergo this first step of photosynthesis. It gives the plant energy, and it gives us energy too. So we can get energy from light. This is a kind of rather new concept. But if you were Mother Nature, and you've done pretty successfully with unicellular organisms and also green plants, and you decided one day, well, I think I'll create some animals. And of course, animals can forage; they can go around and get various food. But if you had this mechanism which worked so spectacularly in, say, green plants, would you discard it in favor of this newer form of energy, or would you actually keep it and use it when necessary, if necessary, to complement the energy that you can get from food? And I think the answer is we actually use this energy in virtually everything we do. It's inside our body. It's just like ATP is thought of as the coin of the realm, the storage of energy for use. I think the easy water, the negatively charged easy water, which carries potential energy, is used in a similar way.
Dr. Pollack, I mean, I don't have all the information you do, but just with what I know and what I'm hearing from you, I actually believe that food that we are getting from the easy water, I believe it's more primary than the food we're foraging for.
I think so too. I didn't want to say it because I don't have evidence as to how much of our energy comes in that way. So I don't like to jump ahead without evidence, but it makes a lot of sense that this energy that we take in all the time, this kind of radiant energy from the sun, which is actually, about 50% of the energy that gets to us is in the infrared region of the electromagnetic spectrum. Roughly half or so is visible. You've got some UV, but a lot of it is infrared, and that's why we feel it as heat. And this energy doesn't go to waste, nor does the metabolic energy go to waste, because of the heat that occurs from metabolism. That's infrared energy, and that energy charges up the EZ or fourth phase. It builds it, and then we have that energy that we can use. So we can get infrared energy from internal sources, from metabolism, and we can get it from the sun, or we can get it from a sauna or something like that.
Am I jumping too far ahead, or if I say that the easy could also be called structured water, or no?
No, not too far ahead. It's exactly right. So
okay.
The term structured water, I think, was coined by Gilbert Ling, but I'm not sure. People had known about some kind of structured water for a long time.
Yes.
It was suggested even 100 years ago that there ought to be another phase of water. And physical chemists were toying with the idea of this, because even 100 years ago, it was clear that if you start with the assumption that there are only three phases of water, the solid, liquid, vapor, and you try to explain simple experimental observations, you run into trouble. Even 100 years ago, they knew that there were so-called anomalies, stuff that didn't fit that theory. So there was a suggestion then that there should be a fourth phase of water. And I'm not sure, but I think the water that both Gilbert Ling and we after him have uncovered represents that fourth phase of water, necessary if you want to explain so many experimental observations, and this is discussed in my later book, which is called The Fourth Phase of Water. Very simple observations, which don't easily admit to interpretation with the standard three phases. But if you add the fourth phase, then they come really clear in simple ways.
Could you give us a few examples? Do you mind?
Sure. Yeah. Okay. Well, you put me on the spot. Okay. So first of all, no, there are a whole bunch of them. I'm just trying to think of which one is maybe most interesting and easiest to explain.
Sure, sir.
One is freezing, right? So I'll tell you first what we found. We found the molecular structure that I've been talking about, the hexagonal sheets, is very similar to ice. The structure of ice. It's not ice, but it's similar to ice. And we found that if you want to freeze water, you can't go directly from ordinary H2O to ice. You must pass through this intermediate phase. And why this phase is interesting is because there have been a lot of anomalies about how water freezes and why it should freeze. Usually, if you want to create a crystalline substance, usually you have to add energy to it. As I mentioned before, you start with water, which is amorphous. It's not ordered at all, and you actually pull out energy, put it in the freezer, right, which takes away the heat energy, and you get ice. Voila! But that doesn't make sense because usually, in order to go from a liquid to a crystal, you have to add energy to get order.
Right.
So something is wrong with that concept. But if you now understand that there's an intermediate phase, and that's easy water, then it makes a lot of sense because the structure is actually getting built. What happens is, you without going into great detail, you're actually adding how to put it in a way that it's understandable without the background material. Let me just say it resolves the thermodynamic issues in creating ice. Okay, so that's one. Another one, the one I keep coming back to is about clouds and how clouds form and why clouds stay up in the air. So we found that clouds are made up of little droplets, tiny droplets, and sometimes the cloud unleashes those droplets and that comes down as rain. But sometimes it doesn't rain. So you're in BC. I think you're in a region where it doesn't rain so much. But here in Seattle, in the winter we get rain quite a lot. And so there are two questions. One question is what keeps the clouds up in the sky? Is the first one. Most people have never thought about that question. They float up there, but the cloud is made of little droplets, and droplets. If you take a pail of water and spill the water, and the little droplets come down to the earth. The gravity pulls them down, but clouds can stay up, and they're simply made of water. Basically, they're made of little droplets of water. And how come sometimes they stay up there and sometimes they don't? Well, so if you understand some of the fourth phase of water, that begins to become clear. And it becomes clear because each droplet is made up of, so people don't think about droplets. And we found that droplets are made up of a shell of easy water. And inside the shell is ordinary water with a lot of protons in it. So the protons repel each other and they push out. And this easy shell restrains that repulsive force. And so you get a spherical droplet. That's why droplets are spherical. But it turns out that in the construction of these droplets, which is described in the book, I won't go into it, but it turns out that the negative charge of the EZ exceeds the positive charge inside. So each droplet is in fact has a net negative charge. So if it has a net negative charge, you can begin to understand why the cloud consisting of the droplets stays up. The cloud has a net negative charge, But the Earth also has a net negative charge. This has been known for 100 years. I didn't know it until recently, but the evidence is very clear and widely discussed. For example, in Russia, where my Russian friend told me that every middle school student knows about the negative charge of the Earth. So one reason why it stays up is the Earth is negatively charged, the cloud is negatively charged, the two repel each other. And so that's why clouds float. It's very simple, and it comes from an understanding from the experiments that we've done about how droplets are structured. Just one more thing before I know you have a long list of questions. If you have negatively charged droplets in the air, any kind of droplets in the air, you've noticed that when you're on the East Coast, for example, or in Asia in the summertime, it's hot and humid. You can't see very far when it's humid. Images tend to blur in humidity, whereas very low humidity, you can see quite a long distance. Why is that? Well, one reason is that the light is coming, say, from a building that's far away. It hits the droplet and gets scattered. Maybe another droplet gets scattered. And by the time it reaches your eyes, it's undergone a bunch of scatterings. And so the light that reaches your eye is not coming directly from the building. It's coming after being scattered a whole lot. That's the reason why things look fuzzy.
So the light is getting scattered from the water?
Yeah, from these little droplets that are sitting in the air. These droplets constitute humidity.
Right.
So, yeah.
And can I ask one more thing, just
Sure.
back up a teeny bit? So I missed it. Why does some of the droplets stay up and some of them come down as rain? Why? And
okay. You didn't miss it. I didn't. I didn't.
Okay.
I didn't come to that. Thank you for reminding me. Well, so what happens when it rains? You probably noticed too is clouds descend. When you can see the mountains, it doesn't rain. But when the clouds descend, so what makes them descend? Well, what makes them descend is positive charge in the atmosphere. The atmosphere is full of positive charge. Positive charge is coming in sufficient quantity. So as they come, they latch on to these negatively charged droplets and reduce the net negativity of the cloud. So the cloud not so negative is not repelled so much from the Earth, and it tends to descend.
Right.
Very, very negative clouds stay far away from the Earth because they're repelled, but as they get positivity, they come down, down, down. When they come down sufficiently, then the cloud will then induce the opposite charge. You know, Faraday's induction. If you have a positive charge near a surface, this positive charge will induce negativity on the surface, and the two will attract each other. Same thing comes down with a cloud. If the cloud gets low enough, it will induce the opposite charge on the Earth just below. So the two will attract each other, and because they attract each other, the raindrops will be pulled down to the Earth. They're actually pulled down. They don't just fall. It's not like a zipper opens and unleashes the water.
Magnetism.
Cloud. So the evidence is that people, 10 years ago, there was a paper published in Nature in which they took high-speed recordings of rainfall, and they found that the speed with which the drops fall can be up to 10 times higher than you'd expect from free fall of droplets because of gravitation. So something is pulling these droplets down to the Earth, and I think it's the phenomenon I just mentioned. It's the electrical charge that's induced on the Earth that's pulling these droplets down, and that's how we get rain.
Would we also call that magnetism, or no?
Well, magnetism is different. A lot of people get confused by the two.
Yeah.
Magnetism is a kind of field which, in fact, is not really well understood. People talk about it, and it's been known since the ancient Chinese, who found magnetite, and they discovered that the magnetite floating, a little sliver of magnetite floating on the water, would always point in the same direction, north. And that was at least 2,000 years ago, probably more. But electromagnetic energy was discovered only 250 or something years ago. Mm-hmm. And the two have been distinct from one another, and they're actually thought of as distinct. But it was James Clerk Maxwell whose famous equations relate electricity and magnetism. So physicists know these equations very well, but the two are actually distinct from one another. So um, um, I'm not sure what to say, because I'm not sure your listeners are interested in a treatise on electromagnetism or electricity and electromagnetic waves and magnetism, but they're definitely related. And sometimes it's a little complicated. Even magnetism is not so easy to understand. It's thought of by physicists as arising from the spin of electrons, either spin of each electron on its own axis or a spin of the electron around the nucleus. Both of those give rise to a so-called magnetic moment. And when all the moments are added up together, you get a magnet. And that's like the magnet on your refrigerator. But electromagnetic energy is different. It's generated by the movement of charges. And the charges could be, for example, embedded in atoms. And they're thought of as moving around all the time. And as they move, they generate electromagnetic fields. So, right. Okay, anyway, but that's going beyond, I think, what
I know. I have another question for you. What about, you know how they talk about, like, with easy water, it has memory, or you can erase the memory, or am I wrong about this?
No, you're right about this. Where to begin? I think many, or at least some of your viewers, listeners, know about the work of Masaru Emoto, the late Masaru Emoto, and he's probably the best known person who has been dealing with memory or information in water. And first, I should mention that most scientists think that first of all, that memory in water is impossible. Don't even think about it, because if you have water, the molecules are moving around at a furious number of motions per second, and all the molecules are randomly oriented. And if you have randomly oriented molecules moving around on a femtosecond time scale, there's no possibility of retaining information, so there can't be memory. So on the other hand, Masaru, or Dr. Masaru Emoto, the late Dr. Emoto, found that he could impart messages, different kinds of messages to water. And he could impart messages by playing certain kinds of music, or by intention toward the water, positive thoughts versus negative thoughts. And he claimed that the positive thoughts gave rise to beautiful crystals, and the negative thoughts gave rise to ugly crystals. And he published a book. And by the way, another one is coming out in 6 months or so. Emoto passed a few years ago, but his son has taken over, and a crew of very well-intentioned and talented people who are carrying on his work. And so most scientists will reject it because, admittedly, by Emoto himself, he cherry-picked his results. So for example, he would project love to a glass of water, and he would then freeze it. And he'd get 10 different images, and he'd pick out the one that he thought most illustrated what he wanted to show. And he claimed that he's a spiritualist, not a scientist, and therefore, and so scientists are highly skeptical, not only because they presume that it's impossible to store information in water, but also because this was not done scientifically. Well, the group now is beginning to change their approach, and we might soon hear from them about their scientific results. But what I think is the reason I'm closely tied to these people is that the evidence that we've obtained, and that's in my 4th phase book, suggests, first of all, that there is a basis for understanding how various kinds of energies can impart information into the water. And secondly, there's massive evidence all over the place for information storage in water. This is not widely accepted. A lot of it is not widely known. We organize a conference each year on the physics, chemistry, and biology of water. And it's a great conference. It's very informal and lots of really interesting features. It's now, this year, it will be in Germany near Frankfurt, easy to get to. And a lot of people love the conference. And at the conference, we typically will have 3 or 4 different presentations demonstrating, empirical evidence showing that water has retained information of some sort. And so with this empirical information and the fact that, and I'll explain in a moment why easy water is capable of storing information, I think we have the beginnings of a basis for a launch of a new, you might say, frontier line of investigation. One that is disparaged by many people, but one for which the empirical evidence is clear. Even among Luc Montagnier, who won the Nobel Prize for discovering HIV, he's deeply into this subject and comes most years to our conference to present the latest. What he's shown is that you can take DNA. He puts, let me just explain because it's so interesting. He puts DNA in water next to water, and they sit together next to one another for a period of a day. And he supplies some external energy. It might be 50 hertz or 60 hertz or something. And then he says that the information from the DNA or from the water surrounding the DNA is sent out somehow and reaches the water, which is sitting next to it, but they're isolated from one another in sealed flasks. Then he takes this water, which he says has been informed by the DNA. He uses it to create new DNA, and the sequence of the new DNA is the same as the DNA that was sitting next to the water.
Wow.
Wow is right.
Wow.
Yeah. Now, he claims it's, I've heard from people who have confirmed his result in different laboratories. There's not much published on it, but it's reported on a regular basis. So this is a kind of finding. Just tell you one more. A Swiss scientist who takes a small petri dish and puts it in a big petri dish. So you have a well with liquid inside a bigger well with liquid, and he puts single-celled organisms in. I forget whether they were paramecia or something. And he measures, and they can't communicate with one another. I mean, there's no possibility of fluid exchange or any chemical exchange. But there is a possibility of electromagnetic exchange. And what he found is that he measures the rate of division of these cells in the central container. And the rate of division depends on how many cells there are in the outer container, which doesn't communicate with the inner container, except possibly by some kind of electromagnetic waves or by light or something like this. So, these are so interesting about information that is conveyed in ways that are unconventional. The experiments are there, people can repeat them and try them. So the question is, how does it occur? And I think we found how it occurs, because if you think about one of these memory sticks, it's got silicon inside, and the silicon atoms are oriented in a 3-dimensional array, a very fixed array. Each one is positioned at a certain point. Well, the easy water is the same. All of the oxygens and hydrogens are arrayed in positions, in organized positions in a lattice. And so just as it's possible to change each silicon atom so that it represents either a 0 or 1 or on, off, it's possible to do the same with each oxygen. It's even better than that, because each oxygen contains 5 different possible states. They're called oxidation state. The typical one we know is -2, but you've also got -1, 0, +1, +2. You can see that in any chemistry book. So it means that each oxygen can have 5 different states instead of 1. And therefore, if you think of an array of an EZ containing lots of oxygens and hydrogens, the capacity for memory, we did the calculation once, I can't remember the result, but it's something like 10 billion times the information density compared to one of these. So all you need to do is to be able to address 1 or 2 or 5 or 10 of these oxygen atoms. And nobody knows how to do that at the moment, but in theory, the capacity for storage of information in EZ water, not in bulk water, ordinary water, is phenomenal. And I don't like to go and make predictions or such, but it seems inevitable that one day it's possible that EZ water, which you can make solid at room temperature, by the way, this has just recently been accomplished, instead of having silicon inside these memory stick or your digital computer, we'll have EZ water inside to replace it. So yeah, the long answer to your short question is information is definitely possible in water because of this EZ phase of water. It's in our body, which means our body is able to take in this kind of information. Some would call it spiritual kind of information. I'm not sure what you would call it, but information from outside can be taken in by the body and used.
So I want all our listeners to understand that easy water is also known as structured water,
right?
And the human body inside is structured water. I mean, you're either going to drink it or your body has to make the water that comes into your body structured, correct? And
that's right.
And that's structured, I think, because that's what facilitates carrying the light energy, communication maybe to the cells and everything else. I know we're kind of jumping a little bit here, but so we know that water is like a library of information, and that you can erase it, replace it. And on a lighter note, I think we better watch out who we hang around with, right?
Excuse me. It's totally true. Yeah. Could be positive information, and equally could be negative information.
Yeah. So you know what? You're picking up information all the time without communication.
Yeah. So your comment reminds me of a book I read by Lynn McTaggart. Do you know?
Oh yes, I do.
So the recent book is called The Power of 8. And what's 8? Well, she demonstrated that that if you assemble 8 people, that's the minimum number. More is okay, but as little as 8. And you then put your intention on healing a single person. Person gets healed, but also the healers get healed. So there's some kind of energy, if she's right, and she presents evidence that she's right. There's some kind of energy that we don't understand. It could be something in the electromagnetic spectrum or something beyond. It could be a kind of energy that we really don't know about yet. But that energy is somehow getting from you to me, or getting from the healers to the healee. It seems to work. I've heard now from numerous people who have reported. I know a healer from Seattle who said she's booked for a year ahead because it works. It seems to work, so people really want her services.
What does she do? She gets what, 8 people together?
No, she doesn't. But Lynn McTaggart, she's a journalist, but she decided to do her own experiments.
Okay.
And she and I can't recall. It's been a while since I read the book. Whether I think the healers are all remote, but they're doing it at the same time.
Oh.
They have one person in mind, and they focus their intention on that particular person. And as she reports, if her reports are valid and maybe validated, but other people have done similar experiments that people can get healed by this. And the question is how or what. And I think the water is absolutely centrally involved in this, because the water is capable of empirically demonstrating of storing information. How that information is communicated, still not clear, and how that energy actually physically changes the atoms or molecules inside the water, still not clear.
Isn't life amazing, eh?
I think it's totally amazing. Sometimes it's hard to sleep when you think about all these possibilities. And in modern biology, the water is almost completely ignored, except we know that we need to have enough of it. We can't be dehydrated. We have to keep hydrated. Otherwise, our body doesn't function very well. And so for me, that translates into the body, all of our cells need easy water. And because that easy water is the same as hydration. Our cells are hydrated by easy water. So as you said a few moments ago, you drink the water and the water gets converted to easy water. Or what you can do is get the easy water directly. So one way of doing that is through a mechanism that you know about, and that is juicing. Take the green plant and squeeze the guts out of it, which basically, and drink it. And basically what you're squeezing is you're squeezing the water from inside the plant cells. And these are freshly grown plants, they're healthy. And so that water from inside the plant contains EZ, just like our cells contain EZ. So by drinking it, what you're doing is you're getting the EZ water directly from the plant. Say thank you to the plant. I appreciate your donating your EZ water from your cells to my cells.
Yeah, I've drank already today. I've got right here, I've got, this is my second quart of carrot juice. So I usually do about 2 quarts of carrot juice a day. And then I structure all my water.
Yeah.
Yeah.
Good for you. Yeah. So that's why you look so healthy.
So I want to ask you a question. So is that the main premise of your latest book? Is talking about easy structured water, or is it about, what is it about? Can you tell me?
Yeah. Well, the book, The Fourth Phase of Water,
Yeah.
Is actually about all aspects of water.
Okay.
It's about evaporation, clouds, what's inside your cell. In essence, what's the role of structured water? What's the structure? How does it work? Where does it get its energy? Some of the things I touched on today. And to my surprise, the book is extremely popular, and anybody can check. I keep thinking, my mother, if she were alive, she'd be really proud. She'd have it posted on her wall, because the reviews on Amazon are amazing. And I think part of it is because my son is the artist and he's very talented. He draws cartoons, and so the book is easily accessible to people without a science background. I tried to make it that way because, if you have a message to convey, it's nice to convey it in a way that's understandable. And so I tried hard to do that with extensive rounds of editing and adding cartoons and easy to understand figures and such. It basically tells the story.
And that book is called The Fourth Phase of Water, right?
The Fourth Phase of Water, easily found on Amazon.
Yeah. 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 And so what are people saying about the book? Tell me what they're saying.
It's a bit embarrassing for me to say, but
well, I'd like to see you get embarrassed. Get more color. Go
well,
for it.
some of them said the new Einstein, or this is the best scientific book I ever read, et cetera, et cetera. Not all of them, but
a lot. And I know that
the reviews the first year or so the book is now out for a few years, and the reviews that have come in recently, they just say 1 or 2 lines. I agree with blah, blah, blah. But the early ones are full of meat, and they're kind of interesting to read. If I feel in a depressed mood, I click reviews and I get into a better mood. So,
well, congratulations. I think that's amazing.
Well, thank you. I appreciate it. I'm working on a new one. And the new one will, my wife tells me, this may be the end of your career because you're being too controversial. And we'll see if it happens. So
can you tell me, is there a name to this new book?
I haven't figured out the name. I have a few candidates. The name usually comes last. But the subjects are interesting.
Well, if it's controversial, maybe it should be called Muddy Waters.
I like that. Muddy Waters. I'll put that down on the list. It's not really completely about water. It's about some of the chapters deal with water, and especially with weather. So nobody understands weather, right? You don't know whether to bring an umbrella to work or not. 50% chance of rain. So what do? You bring a raincoat or you leave it home? You don't know. And the question is, why should that be? And I think the reason is that the atmospheric scientists don't really understand what makes weather. They build very complicated computer models, and they're built largely based on previous patterns of weather. So, if we have clouds to the east and sunshine to the west, and the winds are blowing, and the pressure is so and so, and the temperature from past patterns, we can give you a 50 or 60% chance it'll rain tomorrow. That's not so helpful.
No. Can you tell me a little bit about the new book and the controversial part? Not because I want to be controversial, it's just that's the part that really matters.
Yeah, I mean, controversial. Anything in science that challenges current belief systems is considered controversial, because we all like to stick to our paradigms. We feel secure in our understanding. And someone comes along and says, oh, very nice, but you're wrong because of X, Y, Z. It really works this way, not the way you think.
Mm-hmm.
Well, nobody likes to be at the receiving end of that. I guess I probably fall into the same category. And it's human nature. You can't avoid it. One of the problems with current science is it's structured in such a way that the people who hold the prevailing view are the ones who get to decide whether you get your grant or whether your work is recognized. So it's a hierarchical system. If you're a reporter in the New York Times and you want to find out the latest about the shape of the Earth, for example, you'll go to the experts in the field, and they'll tell you, well, yeah, of course, if it's a flat Earth environment, they'll tell you, yeah, you just look out the window and you can see that it's flat. The Earth is not round, it's flat. And you want to know a little bit? There's some protrusions. They're called mountains, and your readers of the New York Times should know about those little protrusions from the flat Earth, et cetera, et cetera. Some guy comes along, or some woman comes along and says, oh, no, I think the Earth is round, right? And I got some so-called preliminary evidence, and the evidence is I've seen some satellite photos. It looks like a sphere, And also, by the way, I took off from Seattle, and I went around the world, and I came back to where I started. So it seems, and I didn't see the edge of the flat Earth. I looked out the window, et cetera, et cetera. So you put your grant application, you want to study it, you need some money to study it. You go to the granting agency, and the person who receives your proposal said, oh, this is a pretty interesting, really radical idea. If it's correct, it's pretty important. We're going to get the world's most distinguished scientists who know something about the shape of the Earth to review these and see if they're bullshit or if they're actually, if it's meaningful. So who are these experts? The experts are the people who are the flat Earth people. They're the last ones who are going to say, oh, this is a really interesting challenge. We should give them money to pursue their stuff, because if they do it, it means that the reviewers themselves are in jeopardy. Their career is in jeopardy because they've been spending 40 years studying the flat Earth and all of its manifestations, and someone comes along and says, you're all wrong, your career has been worthless. So the system is set up in such a way. So what I'm getting to is that the sentiment is pretty much the same. If I have 2 or 3 chapters and make a suggestion as to how weather actually works, you might appreciate it, and other people might appreciate it because I think it's logical and clear. But the people who are in the field of atmospheric science will definitely find reason to object. And so the book that I'm working on deals with multiple subjects. One is how does weather work? How does it really work? Atmospheric scientists don't, one of them admitted to me, there are 2 things they don't understand. One is how clouds form, and 2 is how evaporation occurs. We've studied both of those, and we have something to say about them. But it's not all. Another question that you've never thought of, perhaps, what makes the Earth spin on its axis every 24 hours? A lot of people don't think about that.
No, I don't know.
Yeah, no, well, nobody knows. The default interpretation is that it got a kick when the Earth started, a kick of energy, and just keeps going around. But, everything runs down. If you take a top, for example, you get it spinning, or frisbee, or whatever, it runs down. Well, the Earth has a lot of inertia, and maybe it persists long. So you can imagine maybe 100 years, or even 1,000 years, but a million years, a billion years, now.
Well, that's because it's spinning out.
Well, if it's spinning out, it should slow down.
I know, I'm just kidding.
Clear that it's slowing down.
Yeah.
Slowing down is by a very, very small amount. So another Another possible interpretation is that it's spinning because some energy, I think energy from the sun, is somehow getting converted into a kind of energy that keeps it spinning. That's so that's another area. Another one is how do birds fly? So this may seem distant from the idea of water, but it's not so clear actually how birds fly. So you say, well, if you're if a student comes to you, a 10-year-old, and says, "Gee, you're the doc of Detox. You're a smart guy. You must know everything. Tell me how a bird flies." And your response would probably be, "Oh, they flap their wings," right? That's what you'd say.
Yeah.
But some birds don't flap their wings, and like, for example, I look out of the view from my Seattle house, and I see Lake Washington and the Cascade Mountains. It's a very nice view. And to the side is a tree, and there's an eagle's nest. And I see the eagles flying pretty much daily, and I see them flying. They may flap once or twice here and there, but basically they don't flap their wings. And they'll glide in the direction into the wind, against the wind, 90 degrees to the wind. And sometimes they'll lose altitude, sometimes they gain altitude, sometimes they'll fly without any change of altitude. And you need to explain this. And the usual default interpretation is, well, they must encounter some updrafts or something like that. There's a lot of evidence that must be wrong. I won't go into it. But the question really is, what keeps the birds up in the air? Anything up in the air tends to sink down by the pull of gravity. So how come the birds can stay up and even ascend? Same with glider planes. How do they do it? So that's another area that's addressed in the book. And another one is, if I ask you, what causes gravitation? I don't know your answer, but I bet you'll say, well, masses attract one another, right? I mean, this is the usual, unless you're a physicist and go into space-time curvature and such, which is for most of us difficult concept. But you'd say, well, masses attract, and then the 10-year-old says, "Oh, gee, that's pretty interesting. But why do masses attract? What's your answer?" I think your answer is not clear. Right?
I would say magnetism, because I wouldn't know what else to say.
Well, you might say it, but I think that the physicists won't agree with you. But in fact, I think you're not, in my view, you're not too far off from the truth. I mean, you can take two things that are not magnetic, and they can attract each other. So it could be some kind of plausibly some magnetic attraction or electrical attraction. Mm-hmm. And I won't give away what's coming in my book, whether you like it or don't like it, but I deal with that issue and what's the cause of gravitation. I think the result, in my opinion, makes some sense.
When's your book coming out? This book?
As soon as I can find the time to finish it. I've been working. My wife tells me I'm running 5 careers simultaneously, mm-hmm. and to do all that stuff, I don't have enough time to work on the book. And yeah. My editing is exacting. I have a couple people who are doing some editing to make it, to convert it from nonsense to readable. Mm-hmm. I also have very scientific people going over it and telling me where they think I've gone astray, mm-hmm. and indeed I have, and I've made changes. So it's got to satisfy me, and my standards are pretty high. So I hope within 1 year it'll be out. And
Beautiful.
I hope so. So we'll see. Anyway, life is very exciting. There are too many things happening at the same time.
Well, I can't wait until your book comes out, because then I can predict the weather.
Well, I think you'll need the key. Let me just tell you, I think the key is charge, charge, the atmosphere, and the charge in the clouds, and the charge of the earth. And if you take those into account, I think in the proper way, you should be able to predict the weather. But not once have I ever heard any weather guru talking about charge. not once. They talk about temperature and pressure. That's it. And pressure changes from terrible weather to fine weather is maybe 1% difference in pressure. Very, very tiny.
Mm-hmm.
But charges and can vary all over the place. Huge, huge difference, for example, from middle of the night to the middle of the day. And also big changes depending on what's going on in the environment. So I yeah I'm excited about this because I think I'm not presenting this book as this is the way it is. I'm presenting this as some hypotheses that are worth considering because you know how it is. As I forget who it was says, even the most beautiful hypothesis can be destroyed by one ugly fact.
Yeah.
So,
but it takes a lot of bravery to even do it, right?
I don't know if it takes bravery. Some people think so. I've been doing this my whole career, starting from, and I don't know why I'm cantankerous, but I want to see truth, and I'm compelled to look for truth, and perhaps I suffer from being naive and not thinking about the consequences of my career. At one time, I thought I was the only scientist who generally comes from you might say, radical point of view, who hasn't suffered the ravages of the Galileo kind of effect. You don't agree with the church, will confine you to house arrest for the rest of your life. I haven't suffered that. There have been a few minor incursions, sometimes a little more than minor, but basically I'm in pretty good shape. I think, despite the radical view. It used to be that there were lots of radical views, but science was kind of like cottage industry. There were not too many people in it, and so if you had a radical idea, for example, like some of Einstein's ideas, they were radical at the time, and they were not widely. Relativity, for example, was widely disparaged, and he won his Nobel Prize not for that, but for the photoelectric effect. But because he won a Nobel Prize, and that also got accepted as sort of legitimate, and people began to appreciate it. But Einstein had to convince only a handful of physicists because there weren't so many physicists. Today, if you're a biologist and you come up with a radical idea like water is at the center of life, for example, which is now a radical idea, you have to convince thousands because there are so many people doing science, so many thought leaders and so many sub-disciplines, and you need to convince them and in order for your idea to gain traction. It's a formidable obstacle that you need to overcome.
Yeah. Well, I guess, the saying is that, sometimes it's harder to tell the truth than a lie, right? And then trying to get everybody to believe it. So it's not good enough that it's the truth. Then you've got to sell it.
Oh, yeah. You've got to sell it. Yeah. I'm really fortunate because the water stuff seems to be basically selling itself. We don't do marketing or anything of any substantial nature. But people tell other people because they like the idea. So I think there's a great future in this. I think that just to summarize, that water is really central for life. Without water, we do nothing, and we know that if we get dehydrated, we can't function very well. Get rehydrated, we do pretty well.
You do amazing, yeah.
Yeah.
And I've been dealing with easy water, structure water, for I don't know, years now, and there's just so much conclusive evidence just how people feel, their moods change, the inflammation comes down, their digestion changes, they sleep better, they think better. So even if I don't have the science all behind it, I do have a little bit, but not much. I just know what I know, and but I will tell you that I think that structured water or easy water is the only water that we should drink. And I really believe that we have to, because today our bodies are being hit with so many invisible things and so many visible things that any load that we can take off of it is just going to help to lighten the load.
I fully agree with you.
Yeah.
Fully agree. Yeah. You know, and we've actually tested some common procedures and substances that have been known, some for millennia, to be really good for health. And in each case, the test shows that that agent builds easy water. So examples, some people and basil and ghee and even aspirin, and they have so many positive health effects, many positive, not just targeting one organ or one process. And we thought that if the effect is so general, it must target something that's very general, and that is water. Water is all over your body. And we did experimental tests on all of those, plus a few more, including CBD, for example. We haven't published that one yet, but they all build easy water, we found. So you just add a little bit of it and the concentration that would be relevant to what's inside your body, and we found the easy expands. So translating that to human, it means if you have turmeric or basil or any of the ones, it's going to promote easy buildup inside your body. And the reason we would hypothesize is you build up the easy water in your body, and any of your cells or organs that are deficient and not working well, they get replenished. And they get replenished with easy water, then they function normally. So so it's really important. Also the same with a sauna. You know, you get it's heat. You get infrared energy. Infrared energy builds easy water in your body. And when you come out, you feel better than when you walked in. At least that's been my experience, and a lot of others. Also walking barefoot on the earth. I know you know about it, but I'm not sure how many. You're connecting yourself to the negatively charged earth. And in order to build easy water is negative. And if you can suck up those negatively charged electrons from the inside of the earth to your body, they're going to go where they're needed the most, to the cells that are least negative and need it. And that negative charge builds easy water. We know from experiments, we put electrons in the water and you get EZ, converts regular water to easy water. So those are just a few of the expedients, very simple expedients that derive from the concept of easy water as to why these long known expedients for health, why they work, at least according to our point of view. It's
That's
cool.
Amazing.
Yeah,
that truly is amazing.
Yeah, so it's exciting for us to venture into these and learn more about how the body works, how the interaction with easy water and the proteins, how they produce function, because people haven't really studied that in great detail yet. It seems pretty clear to us that it's not just the proteins that undergo their folding to do work, but the water that surrounds the proteins, the easy water, is intimately involved with everything those proteins do. It's actually part of the protein.
Because because the easy water is continually creating structure wherever it goes, or alignment, unification.
It is structure, and also it helps align the protein into its unfolded state. See, the unfolded state, which I'm showing as a finger like this, is surrounded by easy water. And then what happens, the evidence shows, as the water melts into ordinary water, that allows the protein to fold in its normal way, and then to do the work of the cell. And then when it relaxes, goes back, the easy water builds up again. And the energy is required to rebuild that easy water. So in the case when your muscle is cramped, for example, muscles they're not usually pathological muscles are not in the relaxed state, they're in the contracted state. You get a spasm, a contracture. They stay that way. And the reason they stay that way is the proteins are folded. And in order to get them unfolded back to their relaxed state, you need to build the easy water. But if you don't have enough energy, your muscles are tired, they don't have enough energy to rebuild it, your muscles stay in a contracted state.
But
You
if
gotta,
you drink structured water, that should help to get
should
the
help.
nerve.
Or if you apply infrared energy, that should help too. Infrared
Yeah.
light.
And drinking. And what about drinking structured water? No.
Oh yeah, yeah,
Okay.
absolutely. Yeah,
Okay.
yeah. So I always like to add one caveat. Theoretically, you drink structured water or easy water, it should help your health. But someone needs to do the test, the clinical test, to find out whether that, I think, reasonable and likely hypothesis is really true. You need to test it. Someone needs to take someone who's independent of any of the companies who produce this various kinds of structured water, take these various waters and have a group of people who are ill in some way, and one group A drinks water 1 and group B water 2, and et cetera, and one group drinks tap water, and watch them for a year or something and see what happens. I think that's a reasonable way of testing what we think should be the case, that drinking easy water should be good for health. I mean, it makes a lot of sense according to everything that I've mentioned and all the stuff that's in my book, but still needs objective tests. If you can convince one of your colleagues who has done well to fund something like this, it would be a gift to humanity. Because everybody, I get so many requests, what kind of water should I drink? And I tell them, I don't know, because someone needs to carry out the appropriate tests. It's not so simple you can say in theory you should drink X, Y, or Z, but that's theory. And we know about theory. It doesn't always hold up.
Yeah, but what holds up is, okay, I agree. I would like to do this test myself, and maybe someday I will. And I mean that.
Yeah.
But the reality is the thousands of people that have started drinking easy water, structured water, whatever we call it, there's just too many testimonials. I mean, you can't have so many people giving such positive testimonials and just say, well, it's subliminal, and especially when their conditions go away.
Yeah, I'm with you on that. Where can one find that those testimonials? Is it there one place, or it's just that as a clinician you've heard?
As a clinician, and
Yeah.
the thing is you know what? We are actually going to create a library of them, and we're going to start bringing them all in. The biggest thing with me was everybody says, why don't you collect all your testimonials? Well, you know what? Just like you, we're so busy doing the work and doing the research, sometimes we just let the testimonials go. We keep some of them because I used to always believe that, putting testimonials up and collecting testimonials was not the right way to go. Do you understand?
Yeah. I hear you. But people need to know it because, as you know better than I, the world's getting sicker, not healthier, and we need to do something about that. And I think water is at the core. I've heard testimonials too, enormous numbers of testimonials, and I'm guilty of the same infraction as you. We don't keep track of those.
Yeah.
Yeah, and people who are in the mainstream will often remark, "You're spending money for structured water? This is crazy. You're a lunatic. Water is water," and this is sort of common feeling among people.
That's like saying light is light. No, that's not true.
Yeah. I agree with you. So these are issues that are really important, and I feel strongly about bringing this kind of water to the world in a way that I'm not sure where you get your structured water, how you make it. We're thinking about ways to make it available to people in a reliable, tested way. We're working on it. We haven't gotten there yet. We put together a little company, and we're limited mostly by investment. We're looking for people who are willing to put some money in, because it's one thing to go from a laboratory demonstration to something that is available to the public at reasonable cost and in large enough quantity. So we're working on that. where do you get? I mean, when you say you drink structured water, how do you structure it yourself, or do you
Well,
purchase?
I use two different structure units. I have one that was from Natural Action, but then I have another one that you know of, and it's completely stainless steel. It's got the gold plating on the inside. It's very heavy. Okay, it's yeah.
You mean alkaline water? Is that what you mean, or
No, no,
some?
no. It's a structured water unit.
Yeah,
It's
I'm not sure which one.
it's under 1,200 pounds of pressure. It's got the crystalline in it, and then it's got gold plating inside of it. So
Okay,
yeah,
I'm not familiar with water or claim to produce it.
yeah.
Yeah, um, maybe they're all properly structured. I'm not sure because we don't study all of these different. There really must be more than 100 companies producing some kind of structured water. I'm amazed. I hear about new ones practically every month.
Yeah, well, Tom that helped to bring us together to do this lecture,
Yeah.
okay?
Oh, yeah.
Yes, that's the structure unit. That's the main
Oh,
one that we like to use, okay?
okay. Right. Got it. Yeah.
Yeah.
Okay. Yeah.
So we sell that one to our clients, patients, and we also have another unit that's not as expensive as that one. So we
Yeah.
sell two levels
Yeah.
because yeah. So we try to offer this to people because we really believe that I really believe that structured water is the way, and I believe that structuring not just the water, but structuring everything you drink and using structured water for helping to protect the foods you eat and even using it to spray on things and things of that
Yeah.
nature. Yeah,
I'm with you on that.
yeah.
Absolutely.
I mean,
Yeah.
structured water has 101 uses and more, right?
Yeah.
Yeah.
Yeah. The world needs to come to appreciate that. It's getting there, but it's a slow process.
Yes, yes. Well, I would really love to have you back on my show when your new book comes out. I mean, because I don't want you to spill the beans now, but when the book comes out, maybe you can spill the beans a little bit more on your book. We can get the name of it. We can get it out there to people because of these are great topics that you're coming out with, and I love it.
Thank you. I appreciate that. I appreciate your potential interest and maybe even your criticism when you read it, see it. So thanks. Thanks for your great questions, and it's been. I mention just one more thing before departing.
Oh, there's no rush.
Well, I need to. I'm departing tomorrow morning and need to get ready for a trip, but
Okay.
and that is our Institute for Venture Science, short IVS, and the institute is another one of my, as my wife says, 5 different careers. Helping to run this organization. And what it is an organization that's devoted to trying to nurture scientific breakthroughs or even revolutions. Um, um, and the way we do it, there haven't been very many scientific revolutions. There have been lots of technological revolutions and lots of promises of scientific revolutions, like we have a promising cure for cancer, and then it doesn't turn out. But I mean, fundamental, like the structure of the atom, or the structure of DNA, or the splitting of the atom, stuff like that. That's really fundamental. Really hard to think of revolutions like that have taken place in the last 30 or 40 years. At least I ask people, and I usually get a blank stare because it's hard to think of one that's in that category. And if you think about why, there's so much science going on and so much money, although scientists complain we don't have enough money, and it's legitimate. But nevertheless, compared to, say, 100 years ago, the amount of money in science is um, uh, so many orders of magnitude higher. And yet, in the early 1900s, there were scientific breakthroughs coming practically every year, especially in physics, but other areas too. But now, the last 30, 40 years, it's really hard to name even a single one that has impacted our lives in a fundamental way.
Well,
So,
I think Dr. Pollack, that's regulated. I think the powers to be are almost regulating us to okay, we'll study this, but we're not going to study that because that might just change things too much.
Yeah, exactly the point. Yeah.
Yeah.
So we're trying to do something about the powers that be, and so we put together an organization, and what we do is we invite proposals, starting with pre-proposals and full proposals, from people who have an idea that challenges the mainstream view, where the mainstream view doesn't seem to fit or no longer fits.
Right.
And we go through this very carefully, and this time we picked out 15 of the pre-proposals that have the capacity, if they're right, of turning the world upside down, of really shaking the world. We invited full proposals. We vetted them really carefully, and we got input from people who would like to challenge them, scathing reviews, and the applicant had a chance to respond to those reviews. And we have people who are, you might say, objective, looking at both sides of the story, and seeing whether the applicant really has a promising point of view. We picked 5 of them. And we're looking for funds. This is not something that the government funds. Governments don't fund stuff like that. They're too conservative. But we're looking for people who have done well in their careers and want to contribute to the world in a meaningful way. And we think this is a meaningful way. The world has so many problems. New technologies can solve these problems, and new technologies come from new science. Science is at the core, at the foundation. We're trying to nurture this fundamental science. And I would encourage anybody who is watching, listening, who's in that position to give me a call or an email or something, and check out the website. It's IV Science, like an intravenous, ivscience.org. Very simple. And you'll see a nice website that describes it in more detail. And I'm happy to converse with people who would like to do something genuinely meaningful for the world. So I guess I'll close on that issue.
Okay, and how can people, if they'd like to donate, what do they do? Do they just go to the ivscience.org?
They can do that for small donations. It's possible to click and PayPal.
Okay.
We're looking for major. Those are useful. We're looking for major ones, and there's a place on the website that will connect ultimately to me, or just email me at ghp@u.washington.edu. And if you forget that email address, I easily found on the web. My email address it's not obscure in any way. So
yeah, they've got Rewind.
Okay, yeah,
they'll be fine, and yeah, that's great.
So anyway, it's been a pleasure, Darrell, and let's keep in contact. And I hope it's been helpful or interesting or useful for you.
It's been amazing, and I do mean that. Everything that you talked about, everything I needed to hear, and I just want to thank you for the validation. And it's nice to have that, and especially from a brilliant man like yourself. And I really appreciate you taking the time, because I know how busy you are and all the things that are going on in your personal life right now. So, sir, from the bottom of my heart, I want to thank you for coming on the show.
Well, thank you. I really appreciate that. Okay.
All right. Well, God bless you, sir, and have a beautiful trip tomorrow.
Okay. Thank you.
Thank you. Bye now.
Bye.
So everybody, don't miss our special live Q&A, and I'll be talking about structured water on August the 14th. That would be a week from today, okay? Don't miss it at 3 p.m. Pacific Standard Time. And to keep you updated on all the dates of all our shows, just check us out at the docofdetoxshow.com, and make sure that you tune in to watch the Doc of Detox show on YouTube or Facebook. And sometimes it's not on one or the other, because sometimes they bump us, or they don't like us, or I don't know, maybe they've got a mood disorder. But anyways, so our upcoming courses, our next course is going to be in October the 19th to the 25th, our Whole Life Coach course. And then our Wolfe Deep Tissue is on October 27th to November 2nd. And then our non-surgical Wolfe Non-Surgical course is on November 5th to 8th. You want to take them all if you want to change your life. If you're a practitioner and you want to shake it up and really bring on some powerful tools, check us out at itioh.com for these courses. International Training Institute of Health, okay? And when you're watching on YouTube, don't forget to subscribe below and make sure that you click on the bell to enable notifications so that you never miss a show. Also, at the bottom right of your screen, you can enable closed captions by clicking on CC button. And why would you do that? Well, basically, okay, you do that because you'd want to help out a friend or a neighbor or a neighbor in another country who doesn't speak English, who might want to just watch this show. And listen, and who's responsible for your health and healing? That would be you, okay? So you need to decide today, is it going to be healthcare or self-care, all right? Make the investment of time and energy, and make sure that you always question authority, question me, all right? And just know this is your show. So if there's anything that you would like to see on this show, let us know. If you've got questions, please let us know. And God bless and have the best day of your life. Bye now. If you're looking for life-saving and life-changing information, well, you've come to the right place. Don't forget to click and subscribe. Stay connected.